long it takes. Okay, and it looks like we're live. My name is Nolan Hartwick, and we are doing a review session tonight. Thank you for joining us, students. I plan to discuss regression. There will be plenty of time for Q&A at the end, if anyone has any questions. Unless there's anything anyone wants to bring up before we begin, let's go ahead and dive right into it. Sound good? All right, so off to the left, well, I don't know where you guys have it, but you guys should see my Jupyter Notebook file with a lot of familiar dependencies. You should all be very familiar with these libraries by now. The only kind of weird thing that you've only seen once is the scipy.stats.linregress that we're going to be using. So we can go ahead and import those. FYI, this activity that I'm doing is very similar to the linear regression activity that we did in class like 2 weeks ago, whenever that was. So next thing I'm going to do is just create some fake data for us all to play with. Basically what we have here is number of days we've been growing bananas, the weight of bananas that we have grown in that time, the amount of rainfall we had on each day, and this column is just a constant, which is going to be really useful when we're doing the multiple linear regression. You don't have to worry about that right now. Any questions on what this data is? Okay. So whenever you have a data set, I'd recommend exploring that data set by creating some simple scatter plots of your data to look for relationships. So here I'm using the pandas plotting function to plot the age column versus the weight column with a scatter plot. And if you just look at the data visually, you can see that there's a pretty clear linear relationship there. Similarly, when I plot rainfall versus weight, you can see that there's not really a clear linear relationship. And it should be pretty obvious to you why that is if you just look at the data or think about it, but don't worry about that. We have one very clear linear regression and one not so clear. So let's start by picking at that really simple one. Let's go back a bit. First off, I need to discuss what is linear regression. There's a lot of different ways to think about linear regression. The way I prefer to think about it is as a predictive tool. If you do a linear regression on two variables, x and y, it's going to give you a tool that will let you predict y given x. In other words, f of x will be approximately equal to y. This is also that's basically what a best fit line is. Note that function, that f of x, is always going to be a linear function because we're doing linear regression. There are other types of regression which are nonlinear. We will cover those at a future date in the class, some predetermined future. So here we have line regress, which is from the SciPy library. And basically it's going to do your linear regression given two data sets, x and y. Remember that our data here is age versus weight. And what it's going to return is a slope value, which is the slope of the linear equation, and the intercept value, which is the y-intercept. It should be very familiar if you remember slope-intercept form from back in, I don't know, middle school or whenever it was taught to you guys. You can see that this linear regression gave me a tool which I can use to predict the weight at any given time x using the slope and the intercept from the linear regress call. The next thing that I can do is actually add my predictions as a new column. Let's call it P of age. And basically what this is doing is telling me, using that best fit line, how what weight should we expect given some number of days have passed? And if you just visually look at this column and this column, you can see that they're pretty similar. We can see this visualization even better by plotting the data and adding the predictions as a line. And if you look at this data, you will see that we have the familiar scatter plot from above, except now we have this best fit line that we got using the lin regress function. And just visually looking at it, it seems like it's a pretty good fit to me. There are rigorous ways you can say that it is a good fit using various types of statistical analysis that I am not going to go into tonight. We'll be discussing those in future lessons as we start doing more complex regressions and analysis. For now, just trust your intuition. You can see that there's a pretty good relationship here. But maybe we can do better, right? Maybe this rainfall, even though it doesn't look like it's clearly related with weight, we think it is, because intuitively, the more rain the crops get, the more they can grow, should help. It's just not clear that that relationship is exactly linear. But maybe there is a nice relationship given both age and rainfall. This is called a multiple variable linear regression. And it's because we have multiple variables, in this case, both age and rainfall. So in order to do this, we can't use the SciPy function. We actually have to use a NumPy function. Specifically, this numpy.linearalgebra.least-square function. And this function works a little bit differently from the SciPy function, in that it's only going to have a constant if you specifically give it data that is constant. And this is why we added that constant column 7 cells up, or however many it was. Apart from that, it works the same way. We have our x parameters and we have our y parameters. And we're trying to find the weights, the y-intercept and slopes that will let you map from this age to the weight. And when I run this, you should see that we get basically the same slope and intercept as before. 0.9618 plus 0.29, 0.9618 plus 0.29. We also get this residual value. And the residual is a pretty important metric when you're doing any kind of regression. The residual is going to tell you how big the error is between your prediction and the actual results, the actual values, the difference between your predicted weight and the actual weight in this case. And as a result, you want the residual to be really small. In this case, it's pretty small. There's rigorous ways of defining what that means, but I'm not going to go into them here. And once again, just trust your intuition when you're looking at these plots. Humans are pretty good at seeing relationships. Mostly too good. So now we're going to go into this multiple variable regression, which works very similarly, except instead of just passing it the age and the constant, we're going to pass it the age, the rainfall, and the constant. And once again, we're trying to predict the weight. Because note that weights, I didn't actually explain this before. So the slope and the intercept are both going to get returned as part of this weights array. And you can see that I'm grabbing them by accessing the individual members of the array. Weights 0 and weights 1. In this case, weights 0 tells you the slope for the age, and weights 1 tells you the slope for the constant, which is basically a y-intercept. Questions, if anyone has any, before I move on? Okay. I see some muted mics. I don't know if anyone is trying to ask a question, but that's okay. So basically, it works the same way as before, except now we add age, rainfall, and constant, and weights will now have 3 values in it, 0, 1, and 2. And we can do it just like before. We get this nice function, which is going to tell you a predicted weight given the age and the rainfall. And we also get this residual value. Notice how this residual is pretty significantly lower than the previous residual using just age. The other thing that I did was actually use my data and use those weights that we returned to compute the predicted weight given both the age and rain. And I added that as a column to our data. You can see that that column is right here, P of age rain. And if you look carefully, you can see that usually it's better than P of age. It should be better. And we can see all of these relationships really clearly if we just, once again, plot the data. In this case, I am plotting age and weight. Because we have multiple parameters, it would probably be best to use a 3D plot, but as we haven't discussed how to do that, and it's kind of a pain in Jupyter Notebook, using just matplotlib, I didn't do it. So here we're just looking at age and weight, but that's okay. We can still plot our predictions using both age and rain and our predictions using just age. And if you look at the predictions, you see the familiar line from before. In this case, it's orange. It kind of cuts right through the data, but the predicted weight given age and rainfall is even more close to the data. It's actually very close to the data. It's not perfect. You shouldn't expect a linear regression to be perfect. If you get a residual of 0, you're probably doing something weird or using it in a way that you're not supposed to, but it's good, better. And once again, there are rigorous ways of stating how much better it is, but we're not going to go into that tonight. Anyway, I thought this might be useful for a lot of you who are looking at relationships between variables, since you can try to use this as a just kind of a guideline for how you can do multiple variables in your regression analysis. And it's pretty straightforward and easy to do. Instead of using the SciPy, you're going to use NumPy, and instead of using linregress, you're going to use this least square function. This is a good time for questions, comments, concerns, if anyone has any regarding this specific activity we just went through.
I'm good.
Okay, well, in that case, I will open it up to Q&A, and if there's nothing, I'll go cover lambda functions. Anyone have any general Q&A about the course?
Let's lambda.
Okay, in that case, I will move on to lambda functions. Lambda functions were going to be covered in last week's review session, but we did not have time. So you guys can open up that notebook if you would like to. So for now, you should all see my notebook on your screen. And I'm just going to go ahead and run through this notebook. And get down to the lambda function section. Okay, lambda functions. A lambda function is a specific tool in Python and many other languages, and it gives you a way to define a function, it gives you an alternate way to define a function, which can be very handy for doing a variety of things. In this block, I'm just briefly creating some fake data. In this case, it's just a list containing the values from 0 to 10. And I'm quickly defining an example function in the way you're all very familiar with. You do def method or function name, whatever parameters you want, and then you return some value from the function. In this case, my function is going to compute a mean. And we can see that it works when we call mean of my data, and we get 4.5. That isn't the only way we can define a function, though. We can also define a function using lambdas, which works similarly, except now we do function name over here, and we set that equal to lambda of some number of parameters. And instead of, we do not have to return directly, it's implied. So this is going to return sum of data divided by len data, just as a result of how lambda functions work. That's just the syntax. And then we can verify that it works by computing the mean of my data using this new function. And verify that it works. Hooray, it works. Let's try with some other value real quick. Data4 equals 22. Hooray, it still works. Note that this is not the typical method of using lambda functions. Usually when you are using a lambda function, it is because you want to define a function and not name it, either because you want to use it immediately or pass it to some other function. Now, what do I mean by pass it to some other function? Well, here's an example of where you might actually use a lambda function. So let's pretend that I have this dictionary and it's telling me the scores for some number of students. In this case, we can see that Andrew has the best grade, Tabitha has the second best, and then Rebecca, and then Ethan. So just really quickly, we're going to convert that to a list of tuples. And my objective here is to sort the tuples according to the score of the student, and then print the top 2 students. So in order to do this, I'm going to use a lambda function. Specifically, I'm going to use the Python sorted function. I'm going to pass it the list of tuples, and I'm going to give it this lambda function to tell it how to find this value, and this value, and this value. This lambda function is going to accept elements from the list and return some value to be used during sorting. I'm also going to go ahead and reverse the list so that the biggest score comes first. And you can see that it works. We in fact get it sorted by score and we get their names. Now, what would have happened if I didn't use the lambda function? If I had just tried to sort them directly? You're going to get this kind of gibberish, and that's just a result of the fact that when Python sorts tuples, it's going to sort by the first value first. In this case, these are strings. So we're just sorting by name, which isn't as useful. This type of thing can be generally useful whenever we have data that's maybe not formatted the way we want it to, or maybe we want to do formatting in some other way. We could even perform a random shuffle using the same syntax by, instead of returning some specific value, you could do a call to random.random and just return a random value and then sort based on the random values. There's a lot of things that you can do with this style of sorted, sum collection, and key equals lambda. Here's another thing that you can do. This is something that I started to bring up in class and then didn't talk about. Let's imagine that you have a data frame and you would like to do stuff with it. So let's just quickly define a data frame. You can see that I have item ID as my index, I have price, and some quantity that someone bought. And this data is super fake, but whatever. Unfortunately, whoever was entering the data entered price as strings and has these messy dollar signs. I don't want those. I want those gone. We showed you guys one way to do it in class. Another way to do it is with the map function and a lambda function. In this case, the map function is going to, given some function, it's going to apply that function to each element in a pandas series object. So it's going to look at each row in price, and it's going to call this function on that value. What does this function do? This function is going to trim off the first character and then convert it to a float. And when we run this, you can see that we have item IDs, and now we have these nice clean prices, and these are numbers that we can do things with. We can ask things like my df price.mean, and it will actually work. As opposed to before where you'd get gibberish. Just to demonstrate, this will throw an error eventually. Hooray. So to summarize, lambda functions are another way to define a function, and they are really handy in situations where you want to define a very simple function that you plan to either use immediately or pass to some other function or object. They're really common when you're doing sortings. They're also common when you're doing map functions or apply functions in pandas. You can look at the documentations for that. Yeah, they're handy. Questions, comments, concerns?
Just that's pretty interesting, actually.
Mostly in these review sessions, I've tried to cover content that seems directly applicable to what you're currently working on, or content that is just general Python knowledge that will hopefully help you in writing better code. And Lambda functions are the latter. All right, well, that's basically all the material I have prepared. If anyone has any questions about the past homework, if anyone has any questions about their current project or would like to discuss it with the rest of the students here, now's the time.
Can you hear me?
Yes.
Okay. I think you might have covered some of this on your last session, which I didn't participate in, unfortunately, but I'll still run the risk. I'm trying to work with Google Maps,
Okay.
actually Google Places for our current project, and it just kind of looked. I'm going through the documentation, which is still a little bit of Greek to me, but it seems like it's difficult to retrieve information. You know, I would like to search within zip codes for information, and some of the documentation led me to believe that there's limits that Google has on how far you can. It seemed like I had to define the place by something such as longitude, or like when we looked up White House, and then I'd have to say, oh, I'll search in a radius of 50,000 meters or something like that, as opposed to. So I'm wondering if you had any insight into that. I'm sure there's a solution that I've missed.
So you should see, I did not turn off screen sharing, so you should see the Google Places API up on your screen right now.
Yeah, I do.
Good. And I'm just going to quickly go through it and see what we got.
Okay. The lambda is interesting.
Yeah.
I don't think I could replicate it immediately, but
it's kind of a narrow thing. It's really handy when you're doing maps and applies in Python.
why maps?
Because basically those are the most common functions that you're going to run into, which accept a function as a parameter.
Okay.
Do you know if the Unfortunately, Sherry, I don't have a lot of experience with the Google Places API.
Okay.
I assume that it returns the full address somewhere in these return values.
It'll return a full address. Yeah, it was just more that I wanted to be able to search an entire.
Well, if you can look up a latitude and longitude for a zip code, and then use a large enough radius, and then filter through the results for addresses that have the specific zip code you want, that seems like it might be a good way to get the information you want.
Yeah.
That kind of makes sense?
Yeah, it does. I just think zip codes are larger than 50,000 meters. You know what I mean? You could literally just keep entering all sorts of coordinates. So I'll give it a try. I mean, I have the zip code list. I'll try to do a loop of some sort.
What are you trying to do exactly? Just look
at some searching within a zip code for information.
Information about what?
Well, like a variety of things. But for example, let's say if I wanted to say how many restaurants, for example, were in a zip code, and what their ratings were, which I think the ratings are a paid service, but.
Looks like the average zip code is 90 square miles, which is about 30 miles on an end.
Yeah, it's way more than 50,000 meters.
30 times 5,280 divided by 3. I mean, it's about 50,000 meters.
Yeah, that's true. All right, I'll see if it's worth the trouble.
Yeah, you might miss some results.
Yeah, you're gonna definitely miss some, right?
For your analysis,
right? And just a general question. Again, maybe too basic, but you were always told to go look at the documentation, and sometimes when I look at documentation, I just don't even have the background to completely understand what it means. Google actually does a halfway decent job, but sometimes with Python, I'm struggling to. I understand what they're trying to say, but there's so much, and I'm not sure, where to put it in terms of our syntax. Do you have any suggestions on how to use our documentation? Because it's the thing we're going to need to rely on long term, right?
The short and shitty answer is that you're just going to have to practice.
Okay.
The more documentation you read, the more familiar with it you are, and the faster you will be able to read it and understand it.
Right.
This is a pretty common layout for Python functions. You'll see the definition at the top, which will usually tell you all of the number of parameters it can have and what their names are. It will give you a brief description of what the function is designed to do. And then it's going to dig into the parameters, telling you what each of the parameters are. It's going to tell you what each of the return values are. And a lot of the time, it's going to tell you what errors the function can raise are. If it's particularly good documentation, you will also get some examples. But that is not always present in every library.
Right.
So it should be present with the libraries you guys are using.
Okay. So could you just go back up to the top for a second?
And sometimes you can find, I know I found some API document like examples in GitHub too. Like some people post it to use there. I found it on a couple of them.
Yeah.
How did
And
you
you
search?
find,
Mhm.
sorry, Sherry, go ahead.
No, so did you search directly in GitHub, or did you,
No,
get led there?
Yeah, I used Google for like I don't know, certain API help or examples, and then you could, if you don't see one there, you can just try tagging GitHub at the end of your search.
Okay.
But yeah, there's some people that will post like examples of how to use it on GitHub. So I know I found like one or two there.
Okay, great. That's a good suggestion. It seems like it's very clever. It's just sort of, another learning curve, right?
Yeah,
Google.
it's kind of like every real field has its own nomenclature and its own style of writing that you kind of have to get used to.
Mm-hmm.
Reading legal text is really hard. I don't know if
Mm-hmm.
you've tried.
Yeah, I've actually read some legal stuff in my life. So at the very top where it says numpy.linl.
So this is telling.
Would you mind reviewing that with me one more time?
So this numpy.len. So the final value after the dot is the location is the final name of the function or object. These values before the last dot are telling you the path to find the object.
Okay.
So you can do, instead of doing numpy, instead of just importing numpy, I could have done from numpy.linl import least square.
Oh, I see. Which is what you were showing as I came in. Okay.
And what is it called actually? LSTSQ.
Okay. Oh, interesting.
And you can see that works, and you can call that function in the same way I was calling it before, except now you don't say np.linout.least square. You can just say, least square.
Okay. Oh, thanks for showing that again. I forgot that we can do that.
Yeah.
Okay.
This is literally the same as the documentation that's available online, but without the pretty formatting.
Right.
So it's usually better to just go online when you have an internet connection.
Okay. So then some of the things that I'm, the videos that I'm watching or the articles that are written, they keep referring to beautiful soup. And I sort of recall that at some point that was included in the program when I looked at it years ago. I mean, not years ago, but about a year ago. What is that exactly?
This is an HTML parser that I have not used before.
Okay.
If it's still in the lesson plan, which it probably is, we should be going over it when we start doing more web devy-like stuff.
Okay.
We start going over Flask and other Python web dev frameworks.
Okay.
Would be my guess.
Okay. And how do we export a CSV file like to our desktop or something from? Because we're always saving something as a CSV, right? But I'm getting the impression that it's actually just saved in the document in Jupyter. Sorry, not Juniper. Is that my understanding correct? I mean, where does it go?
So like let's say I want to save this data, right?
Right.
And do data dot to CSV, I think is the function name. And then I give it some path. Normally, when you guys are doing this, you don't give it a path.
Right.
You just say something like my data.csv. You just give it the file.
Right.
It works just fine. And that's actually going to produce a file called mydata.csv.
Okay, so it does get saved in our
Correct.
thing over there. Okay, I guess I've just never tried to check. So basically, we just put in the full path if we want to put it into the to.
Yeah, if you want to put it somewhere else,
save it from there, download it from there.
Like if you want to put it somewhere else, you do like tilde /
Okay,
desktop.
got it.
Theory this works. Hooray! I remembered how to capitalize things correctly. And in theory, you can see that it's now there. Mydata.csv.
Gotcha. Well, that's fantastic. That's easy.
Uh,
when you were, and I don't mean to hog it if anybody else has a question, but when you were showing us in the Lambda function that we could trim off the $sign before converting to the float, yeah. I realize we've gone over this before in class, but it just didn't completely absorb it. After the float where it has the X and the one. Yeah, would you mind sort of?
So this is called slicing.
Okay, that's right.
And given some object, let's say my object is my name.
Uh-huh.
If that object supports slicing, which strings do, then I can say name 10 or 1: This is going to trim off the first character. I could also do 1 to 5. This is going to get you the characters 1 to 5, basically. It'll be 4 characters.
Okay, now I remember. That's right.
We can also use negative values.
Okay.
Trim off the first character and the last character.
Okay.
And we can use negative values on both sides. If I want the last 5 characters, then this is how I do it.
Huh. So by putting the -5 in that first section, which normally I would have applied to your first name, like how is the computer thinking?
So the computer is saying, okay, I'm going to read back 5 characters from the end.
Oh,
and give you everything after it.
So we don't need to put it into the right side of the.
The right side is the stop, wherever you do the stop. Like this is the last 5, but also trimming off the very last letter.
Oh. Okay.
There is
really clears some stuff up.
There is one final thing that you can do if you have 2 colons in a row.
Okay.
You can actually tell it to what's the word? Iterate differently. Increment differently. And in this case, because I'm using a -1, instead of stepping through in the normal direction, it's actually going to step through in the reverse direction.
Oh.
So this is actually going to reverse my name.
Okay. Really? That's pretty funny.
And you can use that in combination with all the usual things. So in theory, this is going to give me my first 3 characters backwards.
Okay.
Oh, first 4, I guess, for some reason. No, because it's a -0.
Okay.
You should roll with NOLA.
NOLA.
I know, right, Patrick? Patrick? Sounds like your voice.
All right. What else can you do?
Well, I have a question related to this Lambda.
Sure.
And it's this one in particular. So I just sent you a screenshot. But the string that I tried to chop off, so I was wondering, can you, in this instance, take out commas? So I put it in that one. So you see up at the top, my string has the $sign and the commas, and it doesn't allow this function to work because the string includes the commas. So is there a way to kind of like do 3 splices in there and get rid of the commas?
You could do that, or you could use the string functions. Like here, let me make some fake data that makes that make sense. So let's say my DF price, which value do I want? Let's say item 2 is going to be equal to $5,005,9 whatever gibberish. Not gibberish, I need numbers. 2, 3, 4, 5. Say something like that, right?
Yeah.
Yeah, I agree. That is. Ignore this warning. So now we have this really messy one. And if we try to do this, it's not going to work. It's going to get the same error you did because it could not convert this to a float. So instead of just trimming off the first character, let's trim off the first character and also strip commas.
Oh.
That's not the right syntax. Hang on. No, I thought it. No, it only does leading and character. Okay, hang on. Maybe it's like Python string remove.
If you replace quotes that don't have a space in between, that's nothing, right? Nothing is not a character.
It's specifically the empty string. Okay. It is a type of string.
Okay.
So we're going to call replace instead. And now it works. And because it's pandas and there's one value that's like super different from all the others, it's converted them to scientific notation. For reference, replace takes all instances of this substring in the main string and replaces it with this string, which is the empty string. In other words, this is deleting commas.
Okay.
Make sense?
So
that does.
Why did it? So it converted it to scientific notation, but you're asking it to turn it into a float.
This is just a display thing. Those are floats.
Okay, because scientific notation is.
Yeah. Okay. It's just one of the ways that Python will show you a float sometimes.
Okay, so if you wanted to change it and make it look different at this point,
you would probably use. There is like a pandas style.
Okay.
And I think you can use that to force the style of your floats.
Okay. So you wouldn't necessarily couldn't use a. There's ways of converting it that we've used in the past, but you wouldn't use that.
Yeah, because you don't want to change the value. You just want to change
the look. Just the look of it. Okay.
Yeah. This is a part of pandas that I have not used a lot.
Okay.
So I'm not that familiar with it because I have no problem with scientific notation in my data. I prefer it a lot of the times, actually.
I'm just thinking, like, if you wanted to make it easy for somebody else to understand. But I guess that would have in the chart or whatever. Okay.
I would expect anyone capable of reading a Jupyter notebook and benefiting from a Jupyter notebook to be capable of understanding scientific notation.
Okay.
I have a follow-up.
Yes.
We don't have to focus on mine because that number isn't school project related; it's work project related. But
Patrick, your questions are much more interesting than mine.
in general, I've come across this error trying to do some of the homework and I had to work around it. But what does so in this case it says float object is not subscriptable, and how do I mean, I can take that error and Google it and find a way around it, but what does that actually mean?
You get this error, right?
Yeah.
This is happening because you're trying to access values inside of a float. A float is a number. It does not have a 0th element or a first element or elements in general.
Okay, that's okay. See, in that lambda one, I just did what you did with the commas, the replace commas, and then I ended up with that. So I was like, all right.
That's happening because at some point your prices are not all of your prices are strings. Some of them are strings and some of them are floats.
Oh, that's fantastic.
It's handy for you. Easiest way to fix it is probably just to wrap this in string. The issue will be that you will be cutting off the first character. So instead of doing this, let's actually just use strip to remove money signs, and this should work. You see what I did here, Patrick?
Yeah, I'm typing it. So that replaced that. Oh, and you got rid of the. Okay, so that makes it. So you basically you go through, use the lambda to go every row, and then you take the number and you're going to change everything to float, but first you're going to change everything to string, and then strip the $, replace the commas, and then convert it to float.
Correct.
Cool. And that worked.
Hooray!
Woohoo!
So that's pretty cool.
Yeah, in general, if you get blank object is not subscriptable, it's because you're trying to index on that object, and it isn't a collection.
Oh, so so when we did that with the X and then the 1 colon, we were looking for it, but it was already a float.
And and floats don't have a first element. Right. That just doesn't make sense. This will happen with lots of different things. Like functions also, you can't access them like that. Like mean is a function. Let's use that. Mean of 1 function object is not subscriptable. It's happening for the same reason.
Okay. Okay, that makes sense.
Any other questions?
Always, but just they're not coming to my brain this second.
I feel like that's always how it is. As soon as it's over.
As soon as it's over, exactly. I just finished work, so I'm a little bit half-mast right now anyway. 3 a.m. I'll have plenty of questions.
One of the other things that I didn't really highlight when I was doing this regression is that just because a variable doesn't immediately correlate with what you want, like rainfall and weight don't correlate here. They do correlate if you have age. Once you know how old they are and you know the amount of rainfall they had in the previous day, it starts correlating. Which is why there's no correlation here. But when we add rainfall to our regression, it gets better.
That's interesting. So you're trying to teach us to look for something in the future. I mean,
yeah, these types of relationships are very common.
Okay.
Often a variable is useless unless you have some other data associated with it that makes it useful.
Okay, so keep looking if you wind up with something that looks random.
Specifically, if you find something that looks random and you think it shouldn't.
Right, got it.
The only reason I looked here is because intuitively, rainfall really ought to be associated with how well things grow.
Right.
And it wasn't when we looked at it, but it is if you take their age into account.
It's very interesting. Yeah, just pulled it all together.
Well, linear regression is a really powerful and useful tool that will let you make all sorts of predictive models. And some future lesson, we will discuss how you can make better models and be careful when you are doing so, but I wouldn't worry about them now, especially on a project that is due later this week, in theory.
Right.
If any of you are doing regression, I don't know if you are, but I know some groups are.
Okay.
So, yeah. Unless there's any other questions before we wrap this up.
No, thank you very much. I really appreciate that you make this effort.
Right. Well, in theory, this session was recorded and will be available on YouTube.
Cool.
I have not thoroughly tested this, though, so we shall see.
All right.
All right. Thanks, man. Appreciate it.
Take care, all.
Thank you. Have a good evening.
And stop.